Thank you very much. First of all, thank you very much for coming to visit us. I'd like to thank our Malaysian guests coming to Mimar Sinan University today. We are very honored to have you here as visitors. We have strong collaboration with Professor Elias for over several years. We have been exchanging students and staff with University of Technology Malaysia. And I've been also coming and going to UTM for every year or every 2 years, teaching there as well on subjects related to BIM and integration of BIM with GIS and so on. So, like every year, it's a big pleasure to see you here. And this year we talked about sustainability mainly. The subject is related to sustainability and sustainable buildings. The team also, Professor Norbert Lechner was with us talking about sustainability. So this year it was a very much sustainability related topic. I'd like to, I'll give a very short speech. I know your time limitations as well, so I'll speak very briefly on what I work on. Also, we will repeat this in coming months. I'd like to remind that to start with, we have a conference jointly organized with the UTM. It's an ISPRS event in 16th and 17th of October. We will have Geo Advances conference here in this building, Mimar Sinan Fine Arts University. This event is open to international community and is free for our participants from Malaysia. It's free registration. So I'll be very happy if you can distribute this information to your colleagues. I'll send all the material to Professor Elias and I'll get some of your email addresses in the lunch. So I'll be very happy that if you can have many participants from Malaysia, because it's a joint event between Turkey and Malaysia. So looking forward to see you in Geo Advances in October, 16th, 17th of October this year. Okay, we have a work group. I have a work group in working on different areas of integration of BIM and GIS. So I know that most of you are coming from the field of surveying and mapping technologies, which is also my biggest research interest. I've been working in the area after my PhD, which finished in 2006. So it's kind of 10 years I've been into this business of 3D GIS and mapping and integrating all this information from building information models into GIS. Today I'll speak very briefly about our research in BIM and Internet of Things, but my research groups works on several different areas. One area is indoor modeling. We have students working on indoor modeling and tracking of people indoors and how to get most out of indoor models, how we can actually track people, how we can detect people's behavior and put some artificial intelligence there and define their behaving patterns indoors, how we can actually model navigation and behavior indoors, and how we can get information from indoors. So the second area that we look at is how we can actually derive information from cities. This is the area that I'm working for in the last 4 or 5 years. This IoT is Internet of Things. Actually, I was focusing on defining some software architectures, how to integrate information from Internet of Things, these all little devices that's distributed all around the world, everything that are connected to the internet. So it says by 2020 there will be 4 billion connected people and there will be $4 trillion of revenue opportunity, and there will be 25 million apps around mobile applications and also 25 billion embedded and intelligent systems. So everything will be connected to the internet. The basic idea behind it is everything will be connected to the internet and it will produce 50 trillion gigabits of data. And so this is a slide that explains what Internet of Things is. It's basically everything, as you can see on the diagram here, everything will be connected to the internet. So there are a lot of opportunities from the surveying side as well, from the BIM side as well. If we can acquire information from outdoors and indoors, we can use it in many areas ranging from air pollution, sportsman care, structural health, quality of shipping conditions, water quality assessment, smart parking, waste management, water leakages detection, smart roads, smart lighting, electromagnetic level detection, traffic congestion, smartphone detection, and so on, and then noise maps and intelligent shopping facilities. This is why we can get things outdoors, sorry. Also, we can have other opportunities in smartphone and location detection using some beacons and smartphones, and we can utilize this technology indoors as well. Once we are able to detect people's location and people's attributes, and also if we can detect attributes of things, then we say, okay, once we have this information, it will contribute to the big data, the paradigm that you hear every day. It will contribute to the big data paradigm. That this big data is very useful, and we can handle it analytically, and once we handle this big data analytically, it will be very useful in several different fields. So the IoT approach considers the state of things. So every state change, for example, I can attach sensors to everything in this building, everything in this room. I can attach a sensor to this door, or to this microphone, or to this computer. So once the door opens, it gives me information that it's open at the current time. So in a house that's realizing the IoT paradigm, a window will mention that it's open at this current moment, or a door will mention that it's locked at the current moment. And also, things will react to the other things. So the door will let this microphone that is open, then okay, the microphone will stop working once the door is open. So okay, the things will start to talk with the other things. That provides us many opportunities with that. For example, a human-to-thing interaction is another thing. A human-to-thing interaction can be initiated as a result of a cell phone message or SMS for turning the heater before coming to home, or turning off the lights 30 minutes after you leave the office. So your office door will detect that you are leaving the office at the moment, and then, okay, it will turn off the lights 30 minutes later. So these are technologies that we are working on, and there are different hardware components. You can see several of them, and there are different operating systems that we are testing to enable this. Our main aim is getting information from the buildings, and then from the outdoors. The key is getting real-time information. The key thing is getting the information about what's happening now regarding our cities, regarding our buildings. So if we know what's happening now, then we can react to it as soon as possible. And also it's very useful in emergency response situations as well. If we know the fire as soon as it occurs, as soon as it happens, then we can react as quickly as possible. So it's very useful. These all operating systems and architectures and so on, they're very useful in responding as soon as possible to what's happening. We are developing all those types of frameworks. We are using all these frameworks and portals and all these technologies. We're testing it to react as the disasters and all those type of emergency situations as quick as possible, and we are trying to make buildings as intelligent as possible. So these are all the portals and technologies that we are using and testing. For example, we have Tweet.io that we are using, which actually means tweet for devices. So personally we don't tweet, but devices tweet themselves. We install some sensors and boards to the devices, and for example, this microphone can tweet that there's somebody talking to me at the moment, so something like this. There's a lot of discussion on BIM. So the BIM is a model, is a structure, a digital building model. So the role of BIM is enabling integration between different partners in the industry and different applications. So we concentrate on how to actually merge this information coming from the BIM, as you can see from the database layer here, how to merge this information with IoT, with the devices information. So we are defining several architectures and how to get information from the sensors. So you can see the devices there, as sensor nodes, how actually we publish some messages and how we can actually integrate these messages with the building's components, so we can actually have an integrated information set coming from sensors and buildings. We have an integrated set of information. Once we have this integrated set of information, we can then use GIS software to actually manage this information. Once we have this integrated set, then we can put a layer of GIS or WebGIS or whatever, then we can utilize this information to actually make analysis, put a meaning to this information, so we can actually use GIS as a tool to monitor in real time what's happening in the buildings, also monitor in real time what's happening around the city. Also, we can use GIS as a tool to actually monitor the information exchanges between the things, for example, between the door and between the electricity system of the city and electricity system within the building. They can exchange messages, and we can use GIS as a tool to track what's happening all over the city. It shouldn't have to be a traditional off-the-shelf GIS, but we write systems, map-based web map systems actually. We don't use traditional GIS in every effort, but we write web mapping software components actually to track what's happening all around the cities. We are also working with Esri. We are developing some tools for Esri as well. To actually, they are very keen on developing these architectures. Good friend of Professor Elias Marikot Pilok, that we're also working with Marikot as well. Professor Elias knows about it. So it's a very brief talk about what we do here regarding IoT and what's our aims. Hopefully we'll have more collaboration, and we are very happy to host you or come to UTM and teach about all these subjects. Both is possible. So we're very much happy to forward our research collaboration with ongoing research collaboration with Malaysia and Malaysian colleagues. So thanks for coming, and thanks for listening to this presentation. Thank you very much. So Professor Elias, and okay, thank you very much. Thank you. Maybe if you can come to the stage, we'll have a photo together now. Okay. Please, yeah, please. Okay. Yeah, we'll take a photo. Group photo maybe. Group photo, yeah. Yeah. One more, okay.